I went to the lecture on November 30th, which covered the physics of breakfast and was presented by Professor Peter Younger. I wanted to attend this lecture because I love eating breakfast and I wanted to find out more about how physics could be applied to certain breakfast foods. Almost everything I heard in the lecture were topics that I hadn't heard of before and explained phenomena that I also was not familiar with. The presenter started with the topic of coffee. Although that may seem boring, the physics behind how stains are formed is actually pretty interesting. It turns out that liquids like coffee, which contain spherical particles, actually dry differently from liquids made of oblong particles. Each coffee particle is about 1 micrometer wide. As a coffee spill dries, the liquid is able to evaporate more efficiently at the outer edges of the spill. Because of this, liquid at the center tends to spread out towards the edges, which are pinned down and do not move back towards the center. The height still decreases with water loss from evaporation, so there's a change in the overall shape of the spill into a flatter profile. The coffee at the very center flows outwards to replenish what is lost at the edges, and carries the coffee particles with it. Once they reach the edge, the particles are deposited. Once the spill has completely evaporated, there are no particles from the center left to transport, and no water is able to act as a carrier of these particles. Apparently, oblong particles clump together better than spherical particles, which makes it harder for liquids at the center to flow to the sides of the spill. As a result, the stain left behind by particles is even and present without darker edges. There are real-life applications to this phenomenon, like testing for the presence of certain diseases like malaria, or changing the way that ink dries so less is required for printing. This will also reduce the cost of each inkjet cartridge. However, none of these applications are available in the real life right now and are still undergoing experiments. He also talked about eggs and how it is essential to first determine if egg yolk is a solid or a liquid, considering that it becomes harder and takes on solid-like properties after raising its temperature. Eggs are rich in protein, which are held together by weak covalent bonds. By increasing the temperature of the eggs when you cook it, the protein is denatured and unfolds from its original twisted shape. These proteins are now able to form stronger bonds and clump closer together to harden. He also talked about using the UTM, or Universal Testing Machine, during his experiment, which was able to test hard-boiled and raw eggs by comparing their compressive strengths. The final thing he talked about was a phenomenon we often observe after eating a bowl of cereal in the morning. It seems there is inevitably a few pieces that group and coalesce together after the cereal. This is actually called the Cheerio effect. The reason for this attraction is because of surface tension. Molecules in a fluid are attracted to each other because they are hydrophilic. This creates surface tension, which repels against things that try to interfere with this attractive force. The presence of Cheerios in a bowl of cereal changes the surface of the liquid by creating a small meniscus or bump underneath the Cheerio. As a result, the depression in the milk causes the Cheerios to fall in towards each other and clump together. There is then attraction between the milk and the Cheerios, between individual Cheerios, and between Cheerios and the edge of the bowl. After doing a little more research, I found out that the Cheerio effect is not only observed with breakfast food. Apparently, this same effect can be seen in space, although there is a different driving force. Large clusters of galaxies and stars cling closely to each other and leave a lot of empty space between them, like Cheerios do in a milk bowl.